All right, I've got two mics here. Put that one down, start walking around, you can use it. Thank you for the introduction, and thank you for inviting me to speak here. I don't have a lot of time, so I'm just going to jump right into it. My name is Dan Kittredge. I'm a farmer from Massachusetts and the northeast quadrant of the U.S. Background, growing up on an organic farm, mixed operation from dairy and pigs and chickens, ducks, geese, sheep, to mixed vegetables, orchardry, pasture, a full mix of operation. All my life, basically since age 5, we were certified organic since the early 1980s, and really just to quickly move to the points here, principles of biological systems. In my mid-20s, when I got done managing my parents' farm in the summer and traveling the world in the winter, decided I wanted to be a farmer as a profession, and came to terms with the fact that I was not a good enough farmer to make a living. And I'm not sure if anyone here has ever struggled with that foundational conundrum. It's a really wonderful lifestyle and you really love it, but paying the bills without working all the time is sometimes quite a bit of a difficulty. Specifically for me, being brought up in the organic sort of background, I struggled with the fact that our plants were regularly decimated by pestilence or disease in some fashion or another, depending on which family of crops it was. And I had been brought up with this idea that organic was better, and if my plants were sick, then perhaps it was not as good as perhaps it could be. So I engaged on a fairly deep learning process starting 12 years ago to attend conferences, read books, seminars in the wintertime and practicing in the summertime, and in fairly short order was able to get to a point on my farm where pest pressure diminished to near zero, disease pressure just was almost entirely gone, yields were going up, cost of production was going down, functional farm viability was much more plausible. And as I began to put A and B together and achieve results, started to give workshops and courses, and as of 8 years ago, founded an NGO called the Bionutrient Food Association, and have been doing a lot of work across North America doing education about a lot of these principles I call principles of biological systems. So that's really what I want to talk about here today, are some of those foundational principles, how it seems they work, and then perhaps have a few minutes for some of the exciting things that we're in the midst of now. So without any further ado, let me just sort of draw a picture for you, if I may, with my words. I'd like to start with the conversation by talking about how most plants are green, and whether it's a weed or a tree or a bramble or a bush anywhere, plants are green. They seem to cover themselves in the chloroplast, in which occurs photosynthesis. And most people are familiar with this concept. We know that it's carbon dioxide and water and sunlight that are converted into sugar and oxygen through a process that, if you actually look into it, involves some pretty quantum activities, but we don't have time for that right now. The oxygen, we know, is taken from the leaf and injected into the atmosphere, and the sugar, which I'm guessing many people here in this room are aware of, a majority of that sugar in nature and in healthy plants is injected into the soil. We understand that on none of the first 6 days did God invent fertilizer. Plants have evolved the functional capacity to feed themselves in entirety from their environment, and the process of purchasing in products to create imbalances in the system functionally to attract the insects is really good business for agribusiness, but not good business for farmers. And so foundationally, I like to talk about how it is that plants have evolved to grow and how we can manage for the conditions for them to flourish with a minimal cost, if any, of inputs. So foundationally, plants have a gut flora in the same way that we do. We understand that as animals, quote unquote, we think of ourselves as animals, but did you all know that something less than 10% of the cells in your body are human? People know about that one? Right, the vast majority of the cells in your body are not human. They're bacterial and fungal. You are not an animal, you are an ecosystem. We have this thing we're taught, which is that the animals are here and the plants are there and the fungi are here and the bacteria are there. And actually, they're all deeply synergistically interrelated. In the same way that when we're born, there's nobody in between our mouth and our rear end. That whole alimentary canal has no one living in it. And after birth, there's this amazing material that comes out of the mother's breast before milk called colostrum, which has evolved to help establish gut flora. Right? It's only when our gut flora is well established that we're able to digest our food. We have this critical symbiotic relationship with microbes, without which we're dead. It's exactly the same for plants. It's only the gut flora of the plant that facilitates their ability to digest food, to functionally flourish. That's the microbes in the soil, the bacteria, the fungi, mycorrhizal fungi, the archaea. People may have heard of all these different terms. As far as I'm concerned, it doesn't really matter whether you're growing grains or vegetables or fruit trees or pasture. Foundationally, it's the microbes in the soil that flourishing at the bottom of the food chain that are critical for whatever crop it is that you're producing to actually flourish well. And so, principles of biological systems, the microbes are the bottom of the food chain. Creating an environment for them to flourish is critical and foundational for the rest of the process to occur. What are the environmental conditions necessary for microbes to flourish? It's really very, very simple. You must have air in the soil because most of them are aerobic. So how far into your soil can you reach your hand? Is it a quarter of an inch? Is it an inch? Is it 6 inches? I know it's certainly dry right now. Apparently this is not normal, at least for you guys, at least yet. Weather, she is a-changin'. You know, the more we can create an environment where we're able to manage for aeration in the soil, the more we should expect life to function well. You know, I've been traveling across the aisles over the past few days now, and most of the fields that I've been able to look at are managed with pastures and extremely short, right? As above, so below. When the grass is kept at 6 inches or less above ground, the root system is going to be kept at 6 inches or less below ground. The savory people, the holistic management people, you know, who are looking at how nature actually works in the savanna ecosystem, understand that really you want to let the grasses and the swards grow much more before running your animals through them. As above, so below. When you have the root systems reaching down, that is helping to loosen up and aerate the soil. You know, foundationally, there's some simple practices we can do, whether it's with the rippers or the keyline plows, whether it's with the tillage radishes and the sort of various forms of cover crop. There's many techniques that can be utilized to facilitate aeration in the soil. But if you don't have air in the soil, if the soil is tight, you can expect the microbes to asphyxiate, right? They're dead. There's no air, they can't breathe, they're dead, and functionally the bottom of the food chain is not alive, and then we're going to have systemic issues throughout the entire growing season. So this is one of those really simple, kind of obvious things you don't necessarily always think about, but from a foundational standpoint, without air in the soil, really you're going to have systemic issues that are going to be continuing year after year after year. So air is a critical piece of the puzzle. Water, again, another critical piece of the puzzle. Microbes in the soil need water to drink. This is really very self-evident. And right now, perhaps, you are experiencing what occurs when there's insufficient hydration in the soil. It should be self-evident. We should not have to think about this, but in many cases, we don't manage for sufficient hydration. The permaculture community, I think, has some really good strategies for building ponds and water catchment systems. The keyline, people talk about stockpiling water and having it, be able to move through the landscape in a lateral fashion. I'm told it rains a lot around here. I haven't seen any all week. It's been quite sunny, but What we have going on in New England in the northeast corner of the United States is with the climatic irregularities that are becoming much more regular, extended periods of rain and cloudy and cold, extended periods of hot and dry and drought functionally. And so proactively establishing infrastructures on your land to be able to manage for not enough water or too much water, I think are really strategic long-term agendas you can be envisioning. Foundationally, if you do not have a plow pan, if you do not have subsoil compaction, there's this magic process that occurs twice a day as part of the, it's called the tidal force. I'm sure everyone's heard of the tidal force. If you go to the ocean, the water apparently moves up and down twice a day, having to do something with the moon. People have heard of this one. I think it's really quite impressive how it operates. But apparently it doesn't just happen in the ocean. Tidal force is operational on land as well. And if you've got water in your subsoil and you don't have subsoil compaction, then literally the moon pulls the water up from the subsoil through into the root zone and then back down again twice a day. Actually, it's a beautiful breathing process where if you don't have that subsoil compaction, the water moves up, pushes the carbon dioxide out of the soil that the soil life have breathed out. And then as the water moves back down again, the oxygen comes back down into the soil. It's this beautiful breathing process that the soil will naturally engage in twice a day. When you've got subsoil compaction due to historical factors of tillage or whatever it is, this process is broken. And really a lot of systemic benefits that can naturally occur through just the way nature seems to have been designed, those benefits do not accrue to you if you've got that subsoil compaction. So figuring out ways to use a penetrometer, identify if you've got that subsoil compaction, depending on your scale, use a ripper, use a keyline plow, use cover crops, allow your swards to get taller before you graze them. Breaking up that subsoil compaction and allowing for water and air to flow in that environment will really be foundationally very empowering, I think, as far as building system function is concerned. So we've talked about air, we've talked about water, food. Obviously, soil life needs food to eat, as most organisms do. Foundationally, food is in the form of carbon compounds. When the plants are green and they're making sugar, basically the way it works is the plant says, I want some copper. And it takes sugar, adds an amino acid to it or two, and functionally makes food for the microbes whose capacity is to solubilize copper from the soil. So it feeds the copper solubilizers, they eat it, go about their merry lives, make babies, have families, solubilize copper. 2 hours later, they're dead because that's the length of their life cycle. And that copper, which was in an unavailable form in the crystal and soil matrix, is now in a protoplasm form and is soluble and bioavailable for the plant. That process occurs when you have green leaves making sugar and feeding the soil life. But I'm not sure what it's like here in the winter. Where I live, it gets down to 15 below Fahrenheit, which is, I don't know what that is, 20 below centigrade, plus or minus. The ground is frozen. We got, a couple feet of snow on the ground at any given point in time, potentially. So we have periods of the year, and I'm guessing you guys have periods of the year here too as well, where there's not a lot of photosynthetic activity going on, where the plants are not making sugar and feeding the soil life. There must be some residual organic matter that is functionally like, carrots and potatoes and beets in the root cellar, or meat in the freezer, or, sauerkraut that's been put aside, or whatever, however you want to envision it. Traditionally farmers and humans will put aside food in the winter when crops aren't growing. There must be a stockpile of food on the land through the winter for the microbes to eat, right? They don't fly off to the Azores or wherever. In the wintertime, they stay put. And if they run out of food in the wintertime, they die from starvation. And then the soil turns to dirt. And then when you're trying to plant in the spring and there's no life in the soil and it's tight, right? It loses its structure, it compacts. And then that's why traditionally, in many cases, farmers plow the field in the spring, is because the soil is too tight. The soil is too tight because it's not soil anymore, because it's dirt. So establishing good, stable carbon reserves that can be keeping the soil life fed throughout, I think is a really powerful piece of this process. Whether that's allowing the swords to have a little bit more on them going into the winter, so that can be laid down, getting cover crops established if you're doing grains or vegetables. I, as a primarily a vegetable farmer producing most of my money on vegetables, always like to establish my cover crops around the end of August or beginning of September as an understory within the crops that are currently being grown. When frost comes, when the crops are done producing, I'd like to have 1.5 feet or 2 feet of cover crops already established by the middle of October, beginning of November, that can continue to grow. And when the snow comes, that gets laid down. That's a beautiful mulch layer. It's food for the soil life. One minor side note I like to talk about when it comes to carbon. I've heard recently that you've got people here in Britain that are doing this. We've certainly had people in North America that are doing it. The ability to sequester carbon, to build organic matter through agriculture is really an amazing story that has not been well enough told, I think. We're aware of the fact that we have significantly larger amounts of carbon in the atmosphere now than there were, a couple hundred years ago. And these climatic irregularities are being attributed to that excess carbon in the atmosphere. Gabe Brown is someone perhaps some of you have heard of in North America. I can refer to his case, quite readily. 20 years ago, when he started doing more biological management, he had, I think, about a 1.5% organic matter in his soil, and now it's about 11%. He's been increasing soil organic matter levels at about 0.5% per year, year over year, on thousands of acres, through managed intensive grazing, not through composting, not through mulching, not through bringing in organic matter, but simply through the plants making sugar out of carbon dioxide and water and sunlight and injecting that sugar into the soil. That sugar, C6, H12O6, is carbon that's functionally is feeding the soil life, and they're functionally sequestering carbon in the soil, building organic matter. This was his practice, right? As he was learning the process, slowly he's been increasing organic matter levels 0.5% per year. Where he began to stack functions and do it more well, he's been increasing organic matter levels by 1.5% per year, which, if you do the math on the number of agricultural acres there are globally, means that we could bring the CO2 in the atmosphere down 15 parts per million per year, right? From 405 to 390, from 390 to 375, from 375 to 360. It would take about 8 years of agriculture globally being practiced well to bring CO2 levels down from where they are now to where they were in 1750. The power we have as farmers through appropriate management of the soil to address systemic issues, categorically is really quite impressive. We actually are the ones who have the capacity to save the world in our hands and as part of our work. So I consider it to be an honor to be part of this profession. One of the best ways to short-circuit that process, one of the best ways to make it so your farm is not beneficial but is actually part of the problem, is to add fertilizer. The way plants have evolved to eat is by making sugar and injecting it into the soil to feed soil life, which then digests the soil and feed the plant. I liken that to eating food, which is then digested by your gut flora, which is then fed to you. If you're in the hospital and you're getting surgery for some reason or other, and you're put on an IV drip, soluble nutrients injected directly into your bloodstream may be able to keep you alive, but how long does it take of you not eating food for all the people in your gut to run out of food and die from starvation? And that whole process to break down. When you add fertilizer, a number, 534, 10, 10, 10, 0, 52, 0, any of those numbers means soluble, which basically means like an IV drip. It's soluble nutrients going directly into the bloodstream, and when the plant is being fed soluble nutrients directly into its bloodstream, it stops using those sugars to feed the soil. Right, so the best way to short-circuit this process of soil building is to add fertilizer to your soil. I'm not saying go cold turkey, I'm just saying systemically, if you understand how the process works, it not only costs you money, but it's bad for the environment and really builds up imbalances in the plant, which cause it to be susceptible to infestation and disease, which I'll get to in a minute if I have time. Next piece, we've talked about air and water and food. The next piece I'd like to talk about is life itself. From a foundational standpoint, I already discussed colostrum. It's critical to have, good gut flora established at birth. It's, as it is for a cow or a human, it is also for a corn plant or a cucumber plant. They need to have their gut flora established well at birth for them to be functionally healthy, not to be colicky, etc. I would suggest one of the least expensive, most, cost-efficient, most time-efficient things that you can do. Oftentimes I suggest to people, if you're going to take home anything from one of my presentations, please let it be inoculation of your seed. Identifying that we do have this critical symbiosis between plants and the microbes, and ensuring a full spectrum of microbes present at birth or at germination is really very, very powerful. Some people may be familiar with buying a legume inoculant for beans or peas. Azotobacter and Rhizobacter are two microbes who have the capacity of pulling nitrogen out of the atmosphere and, in the nodule on the root of the legume, converting it into a form that's available for plants. And some people will buy a legume inoculant and put it on their seed before they plant to facilitate that process. Understand that there's millions upon millions of different species of soil life, families that are critical for functionality. There are products you can purchase, and there are certainly techniques where you can go and harvest these inoculants from your ecosystem. But if you're going to be, in short order here, I don't have much time to go into the details. If you can ensure a few dozen, or at least a couple dozen families of bacteria and at least a dozen different families of fungi are present on the seed as it germinates, that's an extremely powerful technique for facilitating this overall process. If chemicals have been, applied in your field, DDT historically, glyphosate, you know the names of the compounds. If those have been applied in your fields, they are functionally, among other things, they have killed life, right? Fungicides kill fungus. Like, they're designed to kill that kingdom. And so in many cases, I was, just over in Ireland a couple days ago, I said, apparently you guys don't have any snakes. Have you heard this story about no snakes in Ireland? You're not going to have any snakes in Ireland until somebody brings some back and lets them reproduce, right? If you don't have any azotobacter in your soil, they're not going to reproduce until you bring some in. So it does not need to be something you do for many years. It can be once or twice, and then you're done, you're good to go. But functionally re-establishing a broad spectrum of microbes in the environment is foundational for this biological system to occur. I think we can leave it there for now. Finally, the critical environmental condition that I like to talk about is minerals. For biochemistry to occur. Foundationally, for bodies to be built, we have these things that are called enzymes, which are like sockets and wrenches and screwdrivers. They're tools that are used by life to put things together, to complex amino acids into proteins, sugars into carbohydrates, etc. You need these tools that have a specific size and shape to put things together and take things apart. It's biochemistry. I don't have time to go into it in great detail, but functionally, at the core of these tools, the center of these enzymes are different elements: copper and zinc and manganese and boron and cobalt and molybdenum and selenium and chromium and vanadium and yttrium, right? There's dozens of different elements that are foundationally critical for life to flourish, not just the microbes and the plants, but for us as humans as well. I suggest that as farmers, our work is not just to produce crop, but to produce food. And if we understand that, understanding what is necessary for humans to eat, to function well, actually correlates very nicely with what's necessary for microbes to eat and for plants to eat. And in many cases, I think, conventional systems, quote-unquote conventional systems, post-World War II agronomy, has recommended a really simple set of elements to be managing for. Now, let me just give one example, or a couple perhaps. People who are vegetarians or vegans may have been told at some point in time that they need to supplement their diet with vitamin B12 because they're not getting enough in their plant-based diet. Vitamin B12 is the common name for a compound that's known in science as cyanocobalamin. doesn't really matter except for the cobalt part in the middle, is cobalt. Cobalt is an element like copper or zinc. It's the center of vitamin B12. You can't have vitamin B12 without cobalt. If you don't get enough cobalt as a vegetarian or a vegan or whatever, you become anemic, you become lethargic, you become weak. And if you really don't have enough vitamin B12, you become dead. Right? We are vitamin B12 dependent organisms. We require a certain amount in our bodies to exist. At the core of that compound, B12, is cobalt. We require cobalt to exist. Interestingly, 80% of the species of soil life that have been studied are also vitamin B12 dependent organisms. If you don't have cobalt in your soil, as one example, one element, if you don't have cobalt at sufficient levels in your soil, the microbes simply do not exist. They cannot exist. There's a full spectrum of elements that are necessary for system function. Many of them are anions, which means they leach when it rains. Things like sulfur and boron are critical, absolutely critical for system function. And not having seen enough soil tests around here to say with total confidence, I have seen enough soil tests to say with some pretty high level of confidence that some of those elements, cobalt and sulfur and boron, there's a few others, are really systemically deficient in your soils, and until they're addressed, the biological system will not work, or it'll work at a very low level. It's really exciting, to be really simple and get to the point here, I think, from a foundational standpoint, materials like sea salt or seawater, of which the oceans are made, or rock dust, like basalt or granite, of which the continents are made, contain all the elements we need to remineralize our land. We need not necessarily be purchasing products from the co-op or the fertilizer dealer. I know there's fertilizer dealers here. I don't want to perturb anybody, but I'm a farmer, so I'm going to speak to the farmers. I think we can source everything we need to revitalize our land from nature in a very inexpensive manner. And once again, with inoculation, once you've reestablished the microbes in the soil with remineralization, once you've remineralized your soil, it's not the kind of thing that needs to be happening over and over and over and over again, right? From a foundational standpoint, let's get those environmental conditions in place, allow nature to get back into gear, and then my experience as a farmer has been you can really stand back and let nature do the work. So these are some of the basic environmental conditions that I think are necessary for life to flourish. I don't know how much time I've got left, probably not too much, 10 minutes. I do want to talk about some of the things that we're doing as an organization that people perhaps have heard about that might have some larger implications on your business model, actually, and the market going forward, that are hopefully, and they're designed to support farmers in implementing these practices. The organization that I'm a founder and executive director of is called the Bionutrient Food Association. We coined that word out of thin air to sound kind of wonky and sciencey, to refer to those compounds in food which correlate with flavor and aroma. Our mission is to increase quality in the food supply, and by quality we're talking about nutritional value. If you look at the data that's been collected by the sort of the national agronomic organizations, it's the USDA in the States, I don't know what it's called here in Britain or in Japan, or there's various different countries that have been documenting average nutrient levels in food since the 1930s in many cases, and the trajectory has been going like this, right? The average nutrient levels in food have been going down. There's a really nice corollary chart that looks like this, which is the levels of degenerative disease in the populace. There's a really nice correlation between nutrient levels going down in food and disease going up in the people that eat that food. It seems pretty categorical at this point. There's data coming from all kinds of different directions showing that we as a species are physiologically degenerating, falling apart, getting life-threatening illnesses at younger and younger ages, losing our ability to reproduce. Some really pretty serious issues are occurring, and they seem to correlate very nicely with what is or is not in our food. We have this idea in some circles that a carrot is a carrot, a cucumber is a cucumber, wheat is wheat. There is an average nutrient level in them. But as animals, we actually know much better. Anybody who's eaten a tomato, perhaps hydroponic, in January, from the grocery store knows as an animal that really has almost no flavor, right? You don't feel particularly inspired to eat it. A peach, picked raw somewhere very far away, shipped in a container, gassed to soften up a little bit, and then purchased off the shelf, is really nothing resembling what you may have experienced of a peach picked ripe off of a tree tasting like, right? Actually, as animals, we are hardwired with a very sophisticated set of nutrient monitoring devices called our nose and our tongue. Something like 30% of our DNA is associated with the function of our nose and our tongue. Nature thinks it's really important for us to be able to taste and to smell well. The compounds in food that correlate with flavor and aroma, they're referred to as plant secondary metabolites because the nutritionists haven't found any primary need for them, as in, if you don't have them, you won't be dead. Maybe we can raise the bar. Maybe it's about more than just not being dead. Maybe it's about flourishing and being vital and energized and inspired and conscious and valuable for your environment. Those compounds, plant secondary metabolites that correlate with flavor and aroma, are only built in the plant when the lower compounds like fats and oils and proteins and carbohydrates are built. Right? Only when everything else is functioning well do those compounds that correlate with flavor and aroma show up, and only when this plant is really flourishing are they present in high quantities. So our ability to taste and to smell actually is a really powerful tool for us to discern what is good for us and what is not. In many cases, people don't eat their fruits and vegetables because they don't taste good. You're an animal. You know better. It's not any good for you. Right? As an organic farmer who's been in the movement for 35 plus years now, I'm happy to say that in the States, most of the organic produce is nutritionally no better than conventional produce, chemical produce. It may be less toxic, but nutritionally it's no better. It's relative junk. Most of what we're producing is relative junk. We are paid based on volume and aesthetic. We're not paid based on nutritional value. Interestingly, those compounds which correlate with flavor and aroma are exactly the compounds that make your plant pest and disease resistant also. I don't have time for that probably. We can talk about it during the question section if you want. I really want to get to the point about economic drivers and incentives to do a better job. I've had this idea for, I don't know exactly how many years, probably at least 6 or 8, where that is, if we could give consumers the ability to test nutritional value of produce and choose which milk is better, which carrots are better, which rice is better, etc. If we could choose in the marketplace the crops that are more nutritious, that would provide an economic incentive for the producers to focus on nutritional value as opposed to volume. The technology that this can be accomplished through is called spectroscopy. Functionally, every element in chemistry is a vibration in physics. There's a star called Alpha Centauri, which is a few light years away, which we've not sent any probes to, any spaceships. No one's gone to Alpha Centauri, but if you ask the astrophysicists, they'll tell you with great confidence, Alpha Centauri is made up of 51% hydrogen, 48% helium, and 1% other gases. We know that because hydrogen is a thing in chemistry, but it's a vibration in physics. Helium is a thing in chemistry, but it's a vibration in physics. We can read the light coming off of Alpha Centauri and see what it's made up of. If we can read the composition of stars light years away with a flash of light, I propose we can read the composition of a carrot directly in front of us with a flash of light. Spectroscopy is a technology, it's decades old. Until very recently, it has not been possible for it to be performed by a consumer with a handheld tool that could be purchased at a consumer price point in real time at the point of purchase, at a grocery store or a market. That time is quickly upon us. I have got a first generation, version of a tool here, which is a handheld spectrometer that can be used to flash a light at a crop and get a reading in real time. This is a project that we're working on as an NGO. This is all being engineered totally in the commons. If you want, you can go online and you can see our specs, and you can build one of your own. Building the tool is only part of the process. Understanding what quality is another part of the process. What are the levels and ratios of nutrients, elements, and compounds that correlate with quality? What makes this carrot 15 out of 100 and this carrot 85 out of 100? That's a whole other conversation and a whole other piece of the process, again, which we are engaging in entirely in the commons. We believe that this is a project that is critically important and should not be controlled by any corporate interest. This is something that needs to belong to the people globally, to the smallholders, to the commons. What is quality? And then finally, not only what is a tool you can use and how do you build it, and what are the calibrations that can be used to test what is good and what is not, but most importantly, I would suggest, what are the environmental conditions that correlate with quality? How do you, as a farmer, understand what your limiting factors are? Based on your soil type and your fertility program, the climatic conditions and the cultivars, the microbiome and the management practices. Can you flash a light at a leaf of wheat, at a leaf of cucumber, and in real time, based on a few other data points, understand what your limiting factors are? Understand how to functionally improve the health of your plant so that it may be producing crops that are more nutritious. Our objective is to, focus the conversation on quality. Let's stop fighting bad things. Let's stop identifying enemies and railing against them. Let's get together and focus on solutions. We suggest that if we do accomplish this, and in this tool right now is a prototype, anybody can purchase one at the end of this year to use as part of our research project. We're calling it a developer kit for $300, which is what, 240, 50, something like that, pounds. You can get one by the end of the year and be part of our open source collaborative research project, through which we begin to build the data sets to correlate management practices with nutrient variations, et cetera. Our expectation is that by the end of next year, we will actually have a handheld tool at a consumer price point that'll be in the range of 100 pounds, $150, that consumers can use at point of purchase. And in very short order thereafter, it will likely be in smartphones. And so we will not need to have a standalone tool. It will simply be in the smartphone. And it doesn't need to be in everybody's smartphone, right? How many people does it take going to the grocery store, identifying which varieties of which company's carrots are more nutritious, which company's milk is more nutritious, and telling their friends on social media before we actually can have a groundswell of social action and economic interest coordinated around improving nutrient values, which sequesters carbon, which reverses degenerative disease, et cetera. So it's a very exciting endeavor. We're launching what's called the Real Food Campaign as a project to facilitate this endeavor. It is an open, collaborative, network. We understand that there are amazing organizations, companies, universities, partners globally who might find this to be in their common self-interest. Our objective is not to control this endeavor, but to facilitate a collaborative, open process. So if anybody here knows anyone who's interested in engaging in this process, I'm certainly here for the next couple of days and happy to talk. It's really quite exciting. I hope you've gotten something of value out of this. So I'll stop and give some time for questions. Thank you.
Thank you, Dan. Some really interesting points there. There is a roving mic. Here's the roving mic. Camilla, here you go. If you'd like to just say who you are when you. Well, if there is a question, we haven't got a question yet. But
silence.
Yeah, absolute silence. If you're interested, want to ask a question, say who you are and keep it short.
Hi, I'm Carolyn Heyman. I'm just an amateur gardener, really. But I was interested in what you said about the organic food not having any better nutrient value than the non-organic food.
Yeah.
Can you just explain how that can be?
How that could be? Well, I was talking about what's in the market. And at least in the States, the majority of the organic, certified organic food that's on the shelf is produced in a very conventional manner. Monocultures, tillage, fertilizer, insecticides, fungicides, all certifiably organic. Organic fertilizer, organic insecticides, organic fungicides, but we call it the organic substitution method. When you're doing this monoculture, tillage model, which is really an industrial model, with hybrids that are bred for shipping, but not for nutritional value. This is what the data is telling us, that most of the organic crops that are on the shelf right now are nutritionally very similar to conventional crops. That's not saying that smallholders aren't producing crops of significantly higher caliber, and there's some conventional farmers who are producing crops of significantly higher caliber. The point is that there's a variation, that there's a massive variation which correlates with flavor and aroma, which correlates directly with management practices and environmental conditions. And to put all of our faith in a label or a certification system is kind of like putting your faith in a religion. As far as I'm concerned, we all have the capacity to have a direct communication, a direct connection. We can talk about metaphysics later if you want, but from a nutritional standpoint, our direct connection is our tongue. And if this organic carrot tastes bitter, and you really don't physiologically want to eat it, and that conventional carrot tastes good, your body's telling you what's better for you. And it's just it's more of a continuum than a binary, right? We've got this organic and not organic, and good and bad, and it's really not that simple. We all know life's not that simple. So, yeah.
Hello,
Hi.
Giles Strother. I work for a wildlife trust in Oxfordshire. I have heard, is this true that as CO2 levels in the atmosphere rise, that promotes plant growth, but it also means that plants become less nutritious? Is that right?
There was a paper, an article that was published a few months ago that made that argument. I think it was a mathematician whose idea it was, and a very simple set of things he had done, and a number of logical leaps that were made to put that argument together. We did a really interesting project a couple of years ago in partnership with Cornell University and the Biodynamic Association. People know Cornell is a land-grant university of some significant, intellectual repute, and the Biodynamic Association, people know what the Biodynamic Association is. I think they're, wonderful partners, and if you can find a place where you can get them to overlap, that's great. We took carrot seed and corn seed and literally bought 1 pound of, red cord chantenay carrot seed and split it up, sent it to, I think it was 15 farms in 7 states. Some were organic, some were biological, some were conventional, some were biodynamic. And we said, plant this seed in your soil and grow it the way you grow your other crops, and then send us the carrots back. And we found variations within those carrots of significant nature, like orders of magnitude, variation in nutrient levels, presuming similar carbon in the atmosphere, right? The CO2 levels are probably fairly similar across the eastern half of the United States that year. The same seed was put into the ground. The variations in nutrient levels were categorical, that had nothing to do with the CO2 levels. So, I would suggest more carbon in the atmosphere, more CO2 does correlate with greater plant growth, but greater plant growth where fertilizers are applied means continued nutrient deficiencies, but greater plant growth where you've got a well-functioning microbial ecosystem means more sugar for the soil life, which could entirely plausibly mean better nutritional levels. So, yeah, I think that's a bit of a red herring. There are a number of stories out there, and this is a sophisticated conversation. It's not really simple, thought forms. This is really more of a complex concept, which can be conveyed simply, but one would presume that if what we're proposing to do is obviate the need for agrochemicals, there will be some messaging pushback. Did I say that politely enough? Everybody knows what I'm saying? right? There's going to be, at some point, a public campaign to distract from this point or to, send us sideways. I think the central insight is we are animals. We have instinct. It's really sophisticated. It's called your tongue and your nose. And, beyond all the messaging, beyond all the marketing, beyond all the labeling, you actually are hardwired with the ability to discern. I like to say people focus a lot of this conversation on their drugs, whether it's your wine or your beer or your, coffee, right? Maybe it's not so much here, but in the States, people really pay a lot of attention to their coffee and the flavor of their coffee, the flavor of the wine, the notes, right? The overtones and all that kind of stuff, right? Beer, right? Not just simple beer anymore. It's really beer with flavor, right? If you understand that concept, apply it to carrots, apply it to milk, apply it to beef, apply it to wheat, apply it, the principle applies across the board. Yeah.
Tony Allen from King's College, London. Thank you, Dan, for setting the show off in such a fine style. Your handheld spectrometer, what is its precision? In other words, is it as good as the tongue and the nose?
No. No, nothing will ever be as good as the tongue and the nose. We're getting down to parts per million concentration ranges, which is, I think, reasonably good, quite actually, considering the price point we're operating at. We're not looking so much for one element here or one compound there. We're looking for the patterns. Nature seems to operate with these patterns. Levels and ratios of elements correlate with levels and ratios of compounds. And so what we're looking for is the general patterns. What is something that has been grown in a biologically active soil look like biochemically and mineralogically? What's the spectrum of variation? This whole question about quality, it's really quite interesting how many people talk about quality, which I think they're referring to inherent nutritional value, and how there seems to be no data to back anything up, right? I mean, the permaculturalists talk about how their crops are superior. The biodynamic people talk about how their crops are superior. The organic people talk about how their crops are superior. The local people talk about how their crops are superior. We have better quality crops. Upon what data do you make this claim? What is better and worse? How do we define this? I would suggest that science is a good, center point from which to have this conversation. And our hope is that we can inspire enough people to engage in the process to, actually populate a very large data set, a multi-factor data set, not a single-factor data set, and use epidemiological styles of analysis to really begin to tease out patterns. And it's a conversation and a process. As the biodynamic people would say, it's a process.
And could an unscrupulous supermarket confuse it?
Could an unscrupulous supermarket confuse it? Obviously. Which is why it's incumbent on we the people and the broader social movements to coalesce around this process, and thought leaders to collaborate openly and peacefully, right? I mean, the way the culture seems to be modeled of top-down the patriarchal quote-unquote model, I think is foundationally part of what the systemic issues are that we're struggling with. What we're proposing is a biological model. Only when the mycorrhizal fungi are functioning well, facilitating the nutrient sharing between the roots and the bacteria, only when these virtuous circles of symbiosis are actually functionally occurring does life flourish. We as a culture need to reestablish our own mycorrhizae. We've been tilled, right? We are separate. We are, there's a little group of us here and a little group of us here. Only when we begin to actually systemically coordinate and collaborate do we have a viable shot. And I suggest the social movement globally is massive, right? There's just millions upon millions of really amazing people doing wonderful work, who have very common interests. And our proposition is that the quality of food is a wonderful high ground upon which we can come together, right? We're not saying that we're better than you, that, or anything along those lines, that you're bad and we're good. We're saying who can disagree with food being more nutritious? Like, is this possible that we can stop fighting each other and start working together? And how about food quality as a point around which we can collaborate, knowing that none of us has the answer, but we all have pieces of the puzzle.
Yeah, thank you. Tom Allen Stevens, CPM Crop Production Magazine. Yeah, you talked about the elements of quality
Yeah.
and your spectrometer that measures that. Have you actually identified what specific elements you're looking for, what constituents you're looking for, and you know, whether they're their relative goodness, if you like, or is it just a question of the more the better?
We're specifically not looking for specific elements. We're specifically trying to identify the spectrum of variation broadly, from macro elements to trace elements to, you know, amino acid profiles to lipid levels to secondary metabolites. We propose foundationally we don't know the answer, and that only through a big, broad, open, collaborative endeavor can we begin to tease out correlations, and that it'll be an iterative process, that we may have an opening salvo in a couple of years to calibrate a tool to, which will say this looks like it's 15%, this looks like it's 85%, but we hope that that will continue to evolve over time. Our hypothesis foundationally is that higher levels of those compounds that correlate with flavor and aroma is better. But we can't say that because we don't know, because we haven't done the research yet. It's never going to be lots of vitamin D or lots of vitamin C or, whatever. We don't know. We honestly just don't know. And we propose that we start with that humility and engage the process.
I think that's all we've got time for.
All right. Thank you all very much.